Hello students, today we are going to cover vector and scalar quantities. Now let's define the scalar and vector quantity. A scalar quantity has only magnitude, but a vector quantity has both magnitude and direction. Let's give some examples. Length, area, volume, speed, mass, density, pressure, temperature, energy, entropy, work, and power. These quantities have only magnitude. So we call these quantities as scalar quantities. But displacement, direction, velocity, acceleration, momentum, force, lift, drag, thrust, and weight, they have both magnitude and a direction. So we call these kind of quantities as vector quantity. In the example, to test your understanding of this distinction between scalar and vector quantities, let's consider the following quantities listed below. We are going to categorize each quantity as being either a vector or a scalar quantity. 5 meters, you see that there is no direction, so it is a scalar quantity. 30 meters per second in the east direction, then this talk about the velocity, which is a vector quantity. 5 meter north, this has a direction also, so this is a vector of displacement, which is a vector quantity. 30 degrees Celsius, this is the temperature. Temperature is a scalar quantity because there is no direction. 256 bytes, it is also has no direction, so scalar quantity. 4,000 calories, the energy unit, it has again no direction, so scalar quantity. How we represent the vectors? The vector quantities are represented by a directed ray. So here you see a directed ray. The arrow shows you the direction of the vector. The length of the vector shows you the magnitude. This is the beginning or the application point of the vector. So the beginning application point is called tail, and the end of the vector which has arrow is called head of the vector. And this is the symbol of the vector with a capital letter, and there's an arrow above it. There are several characteristics of this diagram that make it an appropriately drawn vector diagram. First, a scale is clearly listed. For example, if I say 1 centimeter is equal to 5 Newton, so in order to represent a 20 Newton force, I have to draw a 4 centimeter vector. A vector arrow is drawn in a specified direction because the direction is very important. It has a head and tail that we have covered in the previous slide. The magnitude and direction of the vector is clearly labeled. Now I'm going to give you a diagram. It is a magnitude of 20 meters with a direction of 30 degrees west of north. So this is north and this is west. West of north, so you go in counterclockwise direction with an amount of 30 degrees. So this is my vector equal to 20 meters. To represent a vector, we use a capital letter, an arrow above it. If we are talking about just the magnitude of the vector, then we put the symbol in absolute form. Let's do an example. Our scale is 1 centimeter is equal to 4 meters. So in order draw a 20-meter vector, how many centimeters should I use? It is equal to 5 centimeters. So the length of this vector is 5 centimeters. And you see that the direction is 30 degrees west of north. Let's say 1 centimeter is equal to 10 meters. This is my scale. And the question asks me to represent a vector 50 meters is equal to how many centimeters? So the length of my vector will be equal to 5 centimeters. The direction is 30 degrees. When I just say the angle, I begin from the east direction and turn in the counter-clockwise direction with an amount of 30 degrees. And the length is 5 centimeters. 1, 2, 3, 4, 5. Yes, this is my, let's say, a vector. Another example, the question asks me to represent the vector of velocity 35 meters per second with an angle of 270 degrees. So the scale is given as 1 centimeter is equal to 5 meters per second. So 35 meters per second is equal to how many centimeters? So the length of my vector will be equal to 7 centimeters. So I begin from the east and turn 270 degrees. So my direction is in the north direction. So I'm going to draw 1, 2, 3, 4, 5, 6, 7 centimeter length of, let's say, this time a B vector. Now let's represent the given vectors by stating our own scale. Now the first one is 100 Newton in south direction. My scale less 1 centimeter is equal to 25 Newton. So 100 Newton will be represented by 4 centimeter. So draw a vector in the length of 4 centimeter in the south direction. 400 and 800 Newton in 45 degree east of north. So let's say 1 centimeter is 1200 Newton. So 4800 Newton will be represented by 4 centimeters. The direction is the east of north. This is east, this is north. So east of north with a degree of 25 will be in this direction. So I'm going to draw a 4 centimeter vector, making a 45 degrees centigrade with the direction east. And the last two questions, the weight of 500 Newton. Let's say 1 centimeter is equal to 100 Newton, so 500 Newton will be equal to 5 centimeter. So the direction of weight is in towards the center of the earth, so 1, 2, 3, 4, 5 centimeter weight vector. 120 km per hour in west direction, so let's say 1 centimeter is equal to 30 km per hour, so 120 km per hour will be equal to 4 centimeter. So I draw a 4 centimeter vector in the direction of west.